Hi, I'm Crazy German Viper, and in today's video I want to comment on the bridge collapse in Baltimore of the what was the name? Francis Scott Key Bridge. So I'm a civil engineer and I'm specialized in geotechnical engineering and piling foundations, which is what this bridge is sitting on. So I can give some excellent commentary on what actually happened. I've also been involved with fairly big projects. I'm also a software engineer and programmer, and I develop software designed to do the calculus behind solving the structural problems of any sort of structural analysis. As many of us did, the first thing that I was looking for. So when I heard that this bridge collapsed, the first thing that I do as a structural engineer is I look at the replays of the accident and I try to figure out from there what exactly happened. And in this case, it's quite obvious. What happens is a big cargo ship hits one of the main bearings and punches it out, so to speak, and then naturally the bridge is going to collapse. There's nothing that you can do about it. There is nothing to protect against it. There's really nothing that you could do differently. And I can also assure you that by the standards of the 1970s or standards of today, if a cargo ship punctures one of these bearings, it will collapse for sure. And there's really not much you can do about it. So the next thing I did was I looked at the layout of the harbor. This is a very big logistics terminal. There probably is going to be a lot of traffic, a lot of big freighters and tankers going in and out. And they have, just in the entrance of the harbor, they have this massive bridge that happened to collapse yesterday. And I was wondering, like, why would you do that? So the problem, and I see this in engineering all the time, is with structural analysis, with codes, with safety parameters, you can never compensate for bad design choices. And this bridge at this position is a very bad and very risky design decision. If money weren't playing a role, and if the world would be just black and white and simple, I would have built a tunnel there. Easy to say for me, but I also know how challenging it is to build a tunnel, and I also know that it's probably more expensive than building the bridge. And I think with more expensive, I don't mean 20% more expensive, but more like 6 to 12 times, something in this order of magnitude. What I mean by bad design choices is that, in my personal opinion, that's not the right place to build a bridge. If you want to connect these two points, you basically on the piece of paper have three options. You can build a bridge, you can build a tunnel, or you can do a ferry. Ferry is probably not an option that is working because of the high amount of traffic that I assume is rolling over these highways. So you're just left with two options, with bridge or with tunnel. Now a tunnel, as a rule of thumb, is always going to be more expensive. And with more expensive, I mean not 20% more expensive, but maybe like 6 to 10 times more expensive. So this is something to take into account. If you say, okay, this is money that I don't want to spend, then you will have to build a bridge and you will have to make sure that something like this, like happened today, doesn't happen. So if you're only left with a bridge, what you need to do is you have to design a bridge that the bearings of the bridge are protected against ships slamming into it. And here you can see the bearings of the truss structure of the bridge. And you see you have like this concrete support structure. And maybe underneath here is like some sort of concrete slab. And underneath that there is going to be some sort of piling foundation. I'll just draw it schematically here. And this is going to be the seabed. This is a very common way to build structures like these. And this sort of structure also inherits some weaknesses that are natural by the design. One of these is that a structure like this is not really resilient towards horizontal loading. So whether I have a horizontal force that attacks here, like the scenario that we have seen with the big freighter, or down here, these structures are always going to deform dramatically in horizontal direction because these structures are mainly designed to transfer vertical loading, so the loading that comes from the bridge and the traffic. What does that mean? It means that when a ship hits one of these supports, what's going to happen is you're going to deform the entire system. So everything here, the entire thing, you're going to deform that dramatically towards the side, towards this direction. And by dramatically, I mean that with a ship like this, the deformation is probably like 1 foot or even a yard maybe. And what this does is, it is going to imagine like a train where you have a running train and then you deform the tracks. What's going to happen is you're going to derail the train, and in this case what is going to happen is you're going to derail the bridge. So if you introduce very significant loadings here, the weak point of the bridge, the weakest point of the structure is going to be these vertical supports for the bridge. And what is going to happen is these are going to derail at these very points in the same fashion as a train would derail if you messed around with the tracks. So what is going to happen next? Well, depending slightly on the angle of the ship, and you see that the ship is slightly angled, it will basically also deform it somewhat into one of the other directions, and this will determine in which direction the bridge will derail. It will derail for sure, and what's going to happen is then a chain reaction, and that sort of looks like this. In a normal scenario, when you would have the support of the bridge like this, so we're looking now in the direction of the pink arrow here, you would have the loading of the bridge vertically apply right here on top. If it gets deformed and derailed, what is going to happen is that now this force applies a little bit more over to the side, and this is going to, you can already see that, create some sort of bending, some sort of moment in this direction. So basically this entire support wants to now flip over. And this is basically what we have also seen in the video if you look at it closely. And this is also what we see in the video. You see that the bridge, at some point you see the big splashes of water. This is where the initial contact is, so I think it's down there somewhere in the bottom. We don't really see well the level of deformations because remember, it is a very big bridge, so probably 1 foot of deformation or even a yard of deformation you won't really see on the video clip. And now the ship basically comes to a stop and the bearing has absorbed all of the energy, and now you already see it happening. You see that in the beginning where you have like a horizontal motion, like a tiny bit. This might have been a yard right there of deformation, and this will definitely derail the bridge. You see like this snipping up here, and then you see how this column here, it pops away. And now basically this is a kinematic system. So basically now this support has already failed entirely. There is zero support that this support structure has. And now basically the bridge is in free fall. So it will basically just shove away the entire structure, the entire support. And yeah, and then it collapses, of course. So yeah, there's really nothing that you can do about it. It's supposed to happen, and there's really nothing that you can do to protect against it. I've been thinking a lot about how you could save a structure like this. But the big problem and the big issue that you face is the tremendous amount of force that is generated in horizontal direction by any sort of tanker or a freighter. These freighters or tankers, they weigh tens of thousands, if not hundreds of thousands of tons. And if they have a certain velocity, then they pack a lot of kinetic energy. They're going to create a huge impulse, which is going to create a very strong horizontal deformation that is going to always collapse a bridge structure like this. So I don't think that there is anything that you can do to protect against it. The only thing that you can do, of course, is build a tunnel, even though a tunnel is more expensive, but the tunnel and the ship, they don't interfere. Now, this is the part where I want to give some personal remarks on this. Yesterday I was already sure when I heard the news that they're not going to find these 6 people, simply due to the fact that in water at some point, I don't know, like maybe in 1 hour or something, depending on the water temperature, body temperature is going to drop, and then you go in hypothermia and then you basically die. And so I was almost certain that they are not going to find the 6 people that were missing yesterday. There's really nothing you can do after a certain time window expired. So I just want to leave you with the imagination what would have happened if that was happening during the day with a traffic jam on the bridge and without a mayday, with just a ship that lost power and communications and so on. So it's an absolute nightmare scenario, and you shouldn't build bridges in the entrance of your harbor. That's just stupid. You shouldn't do that. I know that is unpopular. I know it's going to cost a lot more money to build a tunnel, but if from an engineering standpoint it is possible to build the tunnel, you should always do it, because any sort of bridge, if you ram a freighter into it, is going to collapse, and there's nothing that you can do about it. One more personal remark before you go out and point fingers or you blame people is that one thing that I don't really like about being a civil engineer or structural engineer or to work in this industry, sometimes, not all the times, but sometimes, is that sometimes it's more about politics than it is about physics. And this is understandable because, you know, at the end, it's the community, it's all the people that are paying for infrastructure project. And so naturally, the best politics wins the prize and defines the project. And so it's easy to just say afterwards, like, you shouldn't have done this or you should have built a tunnel. But unfortunately, this is not how the world works. And the world and society and politics and finance are very complex systems. So this is something to keep in mind before just walking around and blaming people for how can you do this. I hope that this was informative. If you have more questions that I can cover about this issue, I'm willing to make another video answering some of the questions. If you like these sorts of videos, then subscribe to my YouTube channel. I have more videos, mostly not like these, mostly more lightweight and fun videos coming out every day. And with this being said, thank you for watching, and I will see you in the next one.